We want to find the roots of a quadratic equation with leading coefficient greater than 1. And we're given a quadratic equation that is not in standard form. So I'm going to add 30u to both sides and add 25 to both sides. 9u squared plus 30u plus 25 is equal to 0. Don't drop the equal to 0 because without that it's not an equation and there's nothing to solve. There are two options here. I can either recognize that this is a perfect square trinomial. It is in fact 3u plus 5 squared, and therefore the solution is 3u plus 5 is equal to 0. U is equal to negative 5. Subtract 5 from both sides, divide by 3. If I can't see that this gives me 3, this gives me 5, and this gives me 2 times 3 times 5, then I need to factor by the AC method. So AC is equal to 9 times 25, which is 225, and B is equal to 30. Then I'm going to factor 225 until I find the two factors that add up to 30. Because 225 is positive and B is positive, I know that both of my factors are positive. So I have 1 and 225. That doesn't work. 3 and 75. That doesn't work. 5 and 45. That doesn't work. 15 and 15. And there I am. Check. Okay, I rewrite the center term. So I have 9u squared plus 15u plus 15u. I got those two 15s from here, and 15u plus 15u is the same thing as 30u. And then plus 25 is equal to 0. And now I factor by grouping. So this is 3u times 3u plus 5, and this is plus 5 times 3u plus 5 is equal to 0. And then factoring out of 3u plus 5, and that leaves me with 3u plus 5 is equal to 0 from this factor, or 3u plus 5 is equal to 0 from this factor. And again, that is u is equal to subtract 5 from both sides and divide by 3, negative 5/3. So we have one solution repeated. But anytime you have a perfect square here and a perfect square here, check this first.